Howdy everyone, Dr. Nir Regev here. In engineering, we use a lot what we call the least squares estimator, sometimes also known as the linear regression estimator or algorithm. Very well known and very prevalent in a lot of engineering disciplines and statistics, and we will take the next few minutes to discuss that. So the basic model for this estimator is y vector, it's a vector of measurements, equals h, a matrix, times the vector of parameters, theta, plus an noise or error term epsilon. In the general case of the least squares estimator or linear regression, there is no assumption on epsilon or its underlying distribution. However, if we want to get optimal results in the sense of mean squared error, this estimator does meet the Kramer-Rao lower bound for epsilon that is IID Gaussian. Okay, the solution is given by theta hat least squares vector. Okay, hat for estimator is given by the Moore-Penrose pseudo-inverse of H, namely H transpose H to the minus 1 H transpose times the measurement vector Y. Let's see how we use this to fit a straight line, or what we call the best line fit, so to speak. We have measurements, XYs of the measurements, and we want to fit the best line, the best linear trend line here. Okay, so we know that a line, let's say every measurement will be described by a line with a slope of A and a bias of B, interception of B. A and B are the parameters we want to estimate, and we can write it in a matrix vector form. Let's say that we have n measurements, so I goes from 0 to n minus 1. In a matrix vector form, it will look like y vector equals, let's open brackets here and put x0, x0, x1 to x sub n minus 1 and a vector of 1s here times a and b, and there is an error term that is subliminally here plus epsilon, and we know that the estimator for the trend line parameters a and b is, let's call this guy h. So here we will have a and b estimated, least squares estimated, equals h transpose h to the minus 1 h transpose y, where y are the y coordinates of these points, the x coordinates of the points is plugging into this matrix that we built, H, and as you can see, this is a Vandermonde matrix. All right, that's all for today on the least squares. Thank you for listening, and until next time, Regev out.